माइक ऑन कर दीजिए।
Yeah, some problem. No, it's there.
पूरा उतना दूर नहीं जा रहा है। Dr. Yulia, you just say next, I will press it. Don't worry. Okay, you start. जीवन यहाँ बैठ के आप ऑपरेट करो। बैटरी वीक है या क्या है? वेट दूर में नहीं दे रहा है।
अगर कीबोर्ड से नहीं होगा, बाहर को कीबोर्ड से नहीं होगा। डिवाइस
Especially.
Colleagues, dear colleagues, first of all, I want to say that we are very grateful for your organization, our visit in your university, in your country and city. It's very important for us to and for that 2 days for the 2 days when we here we knew a lot of new information about your university, and it seems that we found a lot of possibilities to create collaboration and joint point for creating collaboration between our university and your university, between our country and your country. Really, we have a lot of common points, we have a lot of common direction, research direction, educational direction, and of course we knew and now we saw that in your university a lot of high quality specialists in the different areas work, and in some areas your specialists have maybe more qualifications than our specialists, and this is a point for this is a thing for creating new collaboration between our university too. Today, I would like to say a few words about our university and maybe main direction in the area information technology and artificial technologies. First of all, I want to say that our university, St. Petersburg Electrotechnical University, was founded in 1886. Initially, it was a college, but after 10 years after foundation, this college was reorganized into Imperial First Electrotechnical Institute, and after recognized in the First Electrotechnical University. The first Alexander Popov in 1895 made first demonstration of first wireless telegraphy, and it was the first step in the era of informatization. And Alexander Popov was first elected director of our university, and he made a very great, huge contribution in the development of our university. Today, our university is recognized as first electrotechnical university not only in Russia, in Europe too. Today, structure of our university includes not only electrotechnical direction. Our structure includes a lot of institute and the centers and faculties and the departments within different faculties. The main institute and the centers you can see on this slide. I want to say maybe only about the Institute of Artificial Intelligence. This is not so old institute. In 1919, LETI with Michael Dukakis Institute of Leadership and Innovation established the Institute of Artificial Intelligence on the basis LETI. That time, this institute includes only next research direction as creating cyber-physical system and creation industrial internet system and autonomous vehicles. But today we have more different direction in this institute, and for example, we creating for medicine and physiology kind of artificial intelligence technology in medicine and physiology. First of all, our organization is educational institution, and of course, we are teaching a lot of students. Today we have more than 60 different programs for undergraduate student, bachelor's program, and more than 50 different programs, master programs, maybe from previous years, we saved several programs of specializations, and today we have more than 50 different programs for postgraduate students. I want to say that today we are teaching about 300 postgraduate students, and half of all these students from the other countries, not only Russian students. Our students have full-time and part-time education, and additionally, we have a lot of program for people with high education, for people which have diploma and want to get new skills in new area. We have for these people short program, and I will say a few words later about this program too. In 2020, in the Institute of Artificial Intelligence was also one center was established. This center is a world-class scientific center in medicine and physiology. Our government established this center, and this center we can all researchers in this center we can divide into big three parts. First part is fundamental theory. We have a very good mathematician and specialist in the mathematical modeling, physical modeling, and so on. Second part. We have research in the area of hardware solution, and we are creating new sensors, new devices for health, for medicine and physiology. And the third part is kind of prototyping our method and device, and testing this device and the method and the methodologies in real domain, especially in medicine and physiology. I want to say that we try to base all our artificial intelligence system on the main technology, new technology. This technology was created in our university, and this concept is called co-evolutionary hybrid intelligence. Co-evolutionary hybrid intelligence is the symbiosis of artificial and natural intelligence, and we try to system which combine human and machine in whole entire organism, and by such way that this organism can to evolve together, and each participant of his organism of this system can would be participate in evolution of each other participant of each other agents in this system. We know that hybrid intelligence, this term, this definition, hybrid intelligence, exists more than 30 years, but all approaches to creating hybrid intelligence we can divide into three main parts. You can see on this slide these three parts. First class is the hybrid intelligence, which similar with kind of sum of or combining of human and machine possibilities. For example, cluster, computing cluster and programming. Second class, this class kind of augmentation human by the possibilities of machine. For example, chip in the human head, which improve, for example, memory, human memory, and so on. And the third class, this is partnership of human and machine, when human and machine can solve same task and they divide, distribute roles between each other. We add to this definition three main properties. Cognitive interoperability, mutual development, so-called coevolution, and reflection, self-analysis, and mandatory presence feedback. And all our artificial intelligence system, we try to create using this principle. We use them for creating artificial intelligence system, cognitive architecture. This architecture, first time, this architecture was described by Alan Newell, but we have different from classical cognitive architecture because we introduce human in the making decision loop. Today, as I said already, we have in our team a very good mathematician, and most of our solution maybe based on the newest theory, mathematical theory. On this slide, you can see only example of one of such theory of multi-operation, which allows us to describe the state of objects, phenomena, and different processes using not only two state of this object, true and false, and a lot of uncertainties between these two states, but we can describe state of object of phenomena using a lot of different states and a lot of uncertainties between these states. Of course, a lot of attention we make on the development hardware. Today, all our research in the area of hardware, we can divide into these two classes: development of method for acceleration of arithmetic operation and bit stream calculation. First, development, first direction is based on the Intel FPGA, and both this direction allows to accelerate calculation using MPU, MCU, and Intel FPGA. Bit stream calculation. For bit stream calculation, usually we use GPU and video and so on. And all our project in a different domain, when we're creating this project, we also use this kind of micro schema and so on. With me, in the was arrived specialist, a good specialist in this area, Olga. And if you will have some questions in this area, Olga, I am sure, can tell you more information about this area. Also, one research is automation, the hierarchical design of complex microelectronic sockets with uncertainty of design rules. It means that we are trying to create more compact microscheme, and for it we use virtual grid where we put all elements in more compact form, and after we apply kind of matching of cells. On this slide, you can see part of our project which we realized now, and today, if it is possible, I would like to say a few words about several projects. First project, for example, is creating a hardware system for tensometric tremorography. This system now is ready, and this system now is used in our medical organization, for example, in the Institute of Human Brain for diagnostic Parkinson's disease. This device, this tool is this device is a special tool which recognizes involuntary movement of muscles and human limbs, and using this data we can recognize the critical moment in the disease, and we can not make a diagnosis, because we are sure that diagnosis really need to do medicine with medical education. But our system helps to do the diagnosis and help to predict this disease. Also, one system for monitoring person human state using postometric chairs. We create special chairs. These chairs include 44 sensors of pleasure, and when person sit on this chair, of course, we collect information about position of his body on this chair, and using this information about human position, we can understand what is right now state of human. For example, he is tired or he is nervous, and so on. This system initially we created for railway station, because we know that if operators, if driver of train fall asleep during the work, it can lead to very big accidents. And this system also is important not only for railway station, for road driver on the road, for electric station, and for simply for office workers for increasing labor productivity. Also, one system, a system for identification and correction cognitive disorders. Today we live in the world where we can absorb very highest temp of development, different technologies, information technologies and other technologies. And it seems that all these technologies can have to simplify our life. But sometimes, not sometimes, often, almost always, we need more quickly absorb new information. We need to have a good memory. We need to have good concentration, and so on. And all these technology often lead to increasing loads on our cognitive sphere. And more often people became to be tired and have fatigue and so on. This system consists of three parts. First part, diagnostic module. In this part, we use standard devices for example, EEG, FNIRS, MRI. EEG we use for recognizing problem area in human brain. And after using MRI and our special certain new methodology, we can recognize more detailed point in human brain where we have problem and when and where we can put magnetic beams for improving cognitive function. The next part is a navigation model. This model was created in our university, in our center. This model uses a camera and different controllers for navigate magnetic beam on the problem area of human brain. And the third model is model for therapy. Is a therapy model. This model uses transcranial magnetic stimulation for improving cognitive function. Today,
Yulia, this navigation module, I didn't understand. Just go back to the previous slide. So, how does this camera detect what? Just go back to the previous.
Yes.
Yes. Yeah, this.
We have camera and we have a special head. You can see on this slide. On this head we put a different text and user and our patient wear this head with text during the MRI operation and during the TMS operation. During MRI operation using this text, we create coordinates area, coordinate plate, and we get in result we get coordinates of problem area. And after using the same text and the same head, we can use the camera, recognize and determine that problem area on human head, where we need to navigate our system, our magnetic beam.
This is basically by using this, they put the human skull in that and they find out 3D where is the lesion, problem area, is where is the area in which we are interested in. And then when they go for therapy, the beam therapy or something, so they are able to focus the beam exactly on the problem. Am I right?
Yes, thank you very much. Yes, you are right.
But sir, how the camera is identified this is the big portion or this is the portion?
Because they will tell maybe some signaling because capturing the differential signals.
Dr. Aki Singh is saying correctly. Look at these cameras. They are having infrared camera as well as a stereoscopic view of the brain. So main reason they are trying to find out that where is the lesion in the area which is in the cognitive defect. That's what they get it from here. And this diagram tries to show you the automatic navigation of the camera. And then they have got a couple of equipments like cap and other thing which gives the impulses. If you magnetic simulation is one of the techniques they are taking, that you can give a magnetic simulation which can change the lesion or something like that, and then some software which tells them what to do.
Identification mechanism or what?
Yeah, it's a image processing based identification. After this, I will.
So identification and localization. So localization in the.
So similar to MRI.
See, I'll show you here. There is a diagram here. See, when I take an image of this, generally the temperature difference should make of a normal human tissue and the brain tissue and this, there will be an image. So they have got an image processing system which tells them where is the defect, lesion. Like Dr.
Now I think I have one question on that. How your system is better than any other diagnostic tool?
Yes, a good question. Today, I can say maybe only about our Russian system, but I know that in our medical institutes and organization, we need three specialists. Just improving. We need three specialists. One specialist in AED, MRI, NIRS, maybe only one from the area, yes. And we need two second specialists and the TMS, and we need the third specialist, which will navigate manually, will navigate magnetic beam on the human head, of course. And usually, medicine do it using all his experience and eyes. If we have automatic system, we significantly improve точность, exact.
Oh,
Agree.
Yeah, we understood. Please go ahead. Thank you, Dr. Yulia.
So what about the resolution of your system, like in the MRI, because it is a nervous system, so the resolution must be very high to identify which nerve is defective. So what about the resolution? Is it too high or it is in the range of millimeter order?
Please repeat your question.
So the resolution.
How small lesion it can detect?
How small region?
It can detect resolution.
I don't have information exactly.
What
I
is
didn't
the specification of this FNIRS? What is the resolution? What depth it is going? Field of depth, field of view. Because this device has to be take the image from surface to be some that kind of this thing, and take the images some in form of resolution 1 mm, 2 mm, 0.5 mm, something like this.
I don't have exact numbers.
I will explain it. I have the system.
Okay, Prasad.
I know the details.
Let us
Please
proceed.
go ahead.
Yeah, Dr. Yulia, please go ahead.
This system is a static system, and this system we can use only in medical organization. But today we are creating, this is not a finished project, we are creating to come.
How many electrodes are in the cat? How many? How many electrodes in the cat?
Okay, now we are creating a new system which combine this technology in one wearable device, and at the same time we can detect the cognitive decline, and at the same time we can improve the cognitive function. On this slide you can see these devices is a kind of head which consists of two devices. And also I want to say also only about one project. This project we are starting to realize with your university the system for monitoring of human physiological state during various form activities. For this system, we need only 2 devices. It is very easy because we need only device for measuring breathing and we need only device for pulse. We have methodology which allows to correct pulse using information about breathing. But we have one problem. It seems that the system very easy because we have very easy to buy different devices. But today for breathing we have in the world only devices which similar with mask is not comfortable. And today we are creating new comfortable wearable devices for people for using in daily life. Our university, as I said, is educational institute and for organizing maybe international team, joint team. Often we conduct international school and international training. And during this school and training, we start joint projects. And this project and joint publication, as a result of this project, we are to use for application for government grant, international grant. Additionally, we have a program for people with a high education, and we think that maybe your researchers and teachers can participate in this additional program too. No, and at the end, I want to say that we have the several goals, several tasks of our visiting to your university. This is, of course, conducting joint research with your university, implementation of joint project activity, participation of your scientists and teachers in our educational program, and maybe our research and the teachers in your educational program. And conducting different international school, maybe not only in the area of artificial intelligence, but maybe in different in the other technologies which we can apply in our joint project. Thank you very much.
Thank you, Dr. Yulia. Please come. Yes, Dr. Olga is also going to. Yeah, would you like to respond to some of the discussions? Can we have a few minutes discussion? You can sit here also. But Yulia is a very frontline area of research in neurodiagnostics and also the use of artificial intelligence, data analytics, how do we improve and predict the disease much earlier. Like you showed in Parkinson's, before the actual tremor, which is intentional and frantic tremor occurs.
Yes, of course.
Before that, can you predict much earlier? This is one, using AI platform. The second one is how do we increase the diagnostic accuracy? And precisely, like for example, if there is an epileptic foci after D,
Yes.
can you just do lesion it, or you can do a deep brain stimulations? So for which you need to locate precisely the area. So that is why this research is very important. Maybe some points which our colleagues may like to.
I think
Any point, anybody else? So how does the AI help in this area? What kind of algorithms which you have made? You might have discussed with Dr. Datta. So, how do you integrate the neurophysiologists, the clinicians, neurologists, and the experimental scientists in your program to develop these? Because you need all these stakeholders.
Yes. We think, and several days we were discussing about this topic, how we can create cooperation with your university, and we know that your employees have a very high quality, for example, in the hardware, yes, hardware, and for example, if we consider our last project, in this project, your teams, for example, can create neuromorphic computation device, for example, camera and so on, because this competition of competentions of your university. And we can add in this project creation of small devices of breathing using new hardware approaches, yes, and for pulse and artificial intelligence too. And yesterday, maybe a day before yesterday, we have talk with head of artificial intelligence center in your university, and we understood that you have high skills, very great skills in the area of image recognition, and a lot of projects you are realizing now in this area and using these technologies.
Okay, I think a wonderful talk. Like, you said hybrid intelligence. I'm not from this field, but one question was coming to my mind. You said you combine the human intelligence and the machine intelligence. How do you ensure that they always work in synergistically, or they do not work antagonistically?
Yes. This is very complex questions for all world. Today we are trying to create maybe not so difficult, not so complex project. Now, for example, let's consider simple example. We create this system for monitoring human state using information about breathing. Yes, but breathing, your breathing and my breathing is different. Yes, and initially we create general model using information about all humanity of our East. Yes, but when we have feedback, for example, from human, example, for instance, machine predict that your breath is now better or good, for example, yes, and the human answers not only no, it's false. Human now can say, can give explanation why his breathing now has another state. And today we have a lot of technology, for example, Google Bird and so on, which can recognize entire named entires and create ecological models which we use in future. For adapt the machine to certain human.
So you are able to manage that conflict. Last one question. Are you able to capture EEG when fMRI is being done simultaneously?
Are you able to capture EEG when fMRI is being done simultaneously?
Because
are you able to
simultaneously when MRI is done, and you are also recording the EEG.
I think it's a difficult question. I can think about it. I will ask you an easy question.
No, it's not possible.
It is possible.
What he is asking, suppose you are getting magnetic resonance image.
Yes.
Can you take at the same time EEG, electrical
encephalography?
See, there are sometimes the problem comes, both of them are measuring the electrical impulse. One is taking the resonance of the electrical impulse due to the cobalt which is fed into them. Other is measuring the potential difference between various points. So sometimes they interfere. Sometimes
It's a hardware issue, basically it's a hardware issue.
they interfere.
They might do it separately.
Now I will explain it.
So one small query or question, I just want to understand from my point of view. You talk about the hybrid intelligence. Is it not happening now? What is it that extra you're doing? I mean, it's all happening even now. When we, as human beings, as doctors or as clinicians and everybody, we take the results of machines. And therefore, we also try to put our brains into it and analyze and then come back.
Yes, let's repeat it. Machine collect the experience of all magicians in this area, yes, and using this information for creating that machine kind of is learning during this process, yeah. We need to teach but by the same way to human to teach it. Yes, for example, machine, young magician, for example, when go on his first work, he does not have at that time a lot of knowledge, maybe and skills. Yes, and the machine give explanation of his solution and teach a human too.
Yes, Dr. Kamal,
So,
just clearly pass on the mic.
coming to the data set, so how many patients' data did you take to train your system or run your algorithm?
This is a good question because we know you and we know that today our artificial intelligence is data-driven artificial intelligence, and today we works under the topic how we can come away from data-driven and make our data set less.
They are having, in the projects which Dr. Shivani is involved, they are having the data set of around 2,000 people.
Is it public, sir?
Their own people, not, different types of ethnic group. But obviously, such data set is available on the internet by American University and Brazilian University.
So maybe even some of the data sets can be shared for processing for different applications, if it is possible.
Yes, of course. And for example, our members of our team, some 10, maybe several years ago, not several, 10 years ago, created a data set for AEG signal and how we can use AEG signal for recognize cognitive disorders. And this data set we can share, of course, with your university, and other data set which we collect, we can share with you too, and we hope that your data set we will share with others.
The second way we can collaborate is labeling the data set, because having the right gold standard data set is extremely important to build a robust AI system.
Yes,
so our university team can help you to annotate what we call medical labeling. The expert labeling can be
yes, you are right.
in your projects.
Yes, because the process of labeling is a very hard process and a very long process, and if you can help us and we can help you in this process, I think that this is very important point for collaboration.
I think what Dr. Raval is saying, because we were talking that they have the patient data of their country. I think we should also have it, that what you are saying, so that tomorrow in times to come, we have, Indian standard man data.
Maybe
Some
I
chairs
have
addition.
answered your question because today we talk not only about really fashion, we talk about original casual people on the street, and sometimes we make experience for usual people. In our experiments, our students participate, and for example, a state of tiredness or fatigue. This state. For these experiments, often we invite our students.
No, but if they have the expertise, we can seek their help in generating the Indian technique. That's what I
You have to take it from
Making cognitive resilience would be different in our population.
I will get you the.
Sarika, anything you have as a data science specialist, just pass on the mic, please. Sarika. JK after this.
Yeah, hello. Actually, my question may be quite simple. I just wanted to know whether this term co-evolutionary hybrid intelligence, it is your own term or whether it is some standard term, because I don't know. I have heard about the evolutionary algorithm. So are they anywhere related to evolutionary algorithm, or this is entirely different concept?
This concept really is newest. Only several years ago, we started to talk about this concept, and but now we have some articles in high-ranking journals, and we can share this article with you and more information about this concept.
So is it related to evolutionary, like that swarm intelligence and optimization? Is it related to that or not? Is it related to swarm intelligence?
No,
No, it's not.
It is not a kind of algorithm. This is a theory which combine different principles. We cannot say today, and I'm not sure that we be able to say about a certain algorithm in future. This is only concept, so a set of the principle for creating artificial intelligence system on the basis this concept.
Secondly, I'm sure you must be having artificial intelligence experts. So how could we collaborate as an artificial intelligence expert? Because the Kamal sir said for the annotation, because I think there are so many softwares these days which can do the annotations automatically. So what could be our role?
I think that I have answered your question. Yes, today really have all software and algorithm in the area of artificial intelligence, and I want to know that we
You can sit together and converge. Now,
Just one point I want to raise, because the Russian Science Foundation and the Department of Science and Technology always make a call for research proposal. Probably you know about it or don't know, but there is a joint call of research between India and Russia. And all these topics which are being discussed here can be converted into projects.
Sir, we have
And
submitted one.
support from DST, of Government of India. I mean, our area of interest, and this is very clear here. Their call is on new materials, clean technology, clean energy, smart healthcare and medicine, which you are working on.
Sir, actually, she
Stay
only
tuned.
proposed the topic
Yeah.
through DST and we have
The
submitted.
mic take another mic.
Okay, so she only proposed the topic.
But I think more number of proposals should come.
Yeah.
Like one, there are many other titans working here.
so Kamal,
Showing their interest.
Sarika, JK, then Tanya, all of you know, look at what is that we can do together. She has just started the collaboration.
Excuse me, sir. Sir, we are having a separate meeting for collaboration tomorrow.
Okay.
Sometime with these Sarika madam, Tanya madam, and Rekha madam.
JK Rai also.
Right, sir. just to formulate where we can put in.
Converge and have our collaboration. Besides the one which you have started,
Yes, sir.
what he said, there are many possibilities for collaboration,
Yes,
not only with you, with your colleagues, with your institution.
Yes, yes.
So that is what he is saying, more expand.
I think one,
It becomes 11.
One
and she
image
has
for
also
hyper
lot on
spectral,
autonomous
XAR image,
systems.
Yes.
But you didn't
okay.
highlight that. You
Yes.
have also worked on autonomous systems with America also, but you didn't highlight that.
Yes, we have.
Which is we are writing.
Yes, we have today we have autonomous vehicle labs, and we have labs of drones too. And really, we participated in a competition in the area of autonomous vehicles, and our students win on the third place on this competition.
Shivani,
Okay, sir, actually, we discussed some more collaboration. So we'll be working on like getting data from sensors, maybe SAR or hyperspectral. And she has proposed Dr. Olga, she's a hardware expert. So today only we discuss some more collaboration on that idea.
Very
Getting the images from drone or some other sensors, working on them and coming out with a good product.
Very
She's more interested in a product rather than a research. Yeah.
JK?
Yeah. Dr. Yulia, I have a query, particularly with neurological disorders. So whenever you connect the database, getting the database is a major challenge, then solving it with an AI platform or an algorithm. Like your example, which sir was discussing about Parkinson. So by the time the patient realizes and approaches the doctor to get the database, that early part is already lost, I guess. So how do you get the data set at an early stage which can be used? How you are acquiring those data sets at an early stage? Am I clear?
There is some disease, how do you get data in the early stage? Because it gets diagnosed in the later stage. So how do you get data of an early stage for a disease?
That's
Shivani,
we are monitoring the skeleton, that is for her. Whenever
how
we
we collect
monitor
all the
the
data about Parkinson's disease.
At an early stage.
for the onset
So
of
may I answer
Parkinson's
this?
disease.
So may I?
Yeah.
Okay, so that we are doing in our lab. So we are capturing skeletal data. So that is related to the points, skeletal points. So by that skeletal data, we can monitor the pose and the way of walking of a person. So that gives us an indication whether a person is prone to such kind of disease or not. So that can give us an idea. So that may be considered as the initial state of the disease.
Here, this
Sorry, I want to add a little information about Parkinson's disease because that project which we talked before about before this last project we collect the data using mobile phone and all sensors, lot of sensors in mobile phone. For example, sensors for recognizing movement of phone and kind of different position of the phone. Yes, but we know that tremors is not mandatory for all patients with Parkinson's disease. Sometimes a patient has Parkinson's disease, but does not have the tremor. But the small movement of his limbs and specific of his movement in general can recognize this disease on the first stage, but our system does not make disease diagnosis. Our system only recommends to go to visit to doctor.
See, I think my suggestion is tomorrow, since they are staying, and you sit together, identify the areas for collaboration where we have strength. Because in any collaboration, you should be able to give something and get something. So you should be able to say, this is what I will contribute, this mission, and this is my roles and responsibility. This is what they will get. So let you define that. And so thank you very much for both. Olga, you would like to say anything? Usha,
colleagues,
रशियन में बोल दीजिए
You speak in Russian.
We can get organized.
And she will translate.
Every language.
Yes.
English में ही समझ में सब किसी language बोलती है.
Dear colleagues, I and Professor Julia, we very glad to participate.
No, इसको पास रखें.
We very glad to participate in your meeting, and we so very various results of various research in MIT University. We think that our collaboration will be organized, and we obtain the new skills as your students and our students and researchers. And we think that your colleagues will come to Russia.
Спасибо.
Really, I like this discussion and a lot of your questions, because for me this is very important. It means that you are very interested in this topic, and we can create collaboration. We can create collaboration with you. And it means that we can continue our discussion on the different directions. Thank you very
And
much.
also, I would urge our colleagues to visit Russia. There are very good laboratories are there. Good work is happening. Earlier, ILTP used to be there. India long-term program of cooperation between India and Russia. ILTP.
Really, I hope to see you in St. Petersburg in our please.
I would request all of you to stay back, please. Because I have another 5 minutes, 15 minutes, I need you for an important discussion. Yeah, and we'll come back. Thank you. We have a small moment. Please sit down, all of you.
Shivani? We always will be here. We meet.
Please come. एक ऐसे यहाँ पे ऊपर मेरा जो
Thank you. Thank you.
इनका किस दो This is also yeah. Okay. Both of you.
Can I take liberty of putting on your shoulder?
Small token.
Thank you very much. Enjoying your stay here in India, as well as come more often to Amity. We'll be very delighted to host you. Shivani, you can take them. I want to discuss very important issue.
Sure.
Them. We have 15 minutes. Huh?
Sure.
I'm taking. Thank you. Thank you. Yes, be there. So you stay here.
I have to.
Suchendra stay.
You take them.
All others can move. Huh? Come for Sujata. Yaha jo. Sujata. No, please stay back. I want to discuss two important projects where I need to work. 5 crore, one is 5 crore project, and the other one is a very interesting project where I need all your cooperation. I want actual involvement of you. That is why I have requested you to stay back. Thank you. Thank you. So I want to inform you, good development, two major projects are coming. One from Navy, which is going to be 5.4 crores, 5.4 crores. It is a remotely operated vehicle, ROV. Prasad, you have any presentation on this? Yeah. So this is one in which you need, the problem definition I'll give you. You need to implant bombs underwater, like mines, underwater mines. You have to keep it in different places. So you can't risk a human being, a diver going down and putting the bomb. So you have to develop a robotic, autonomous, tethered vehicle which will carry at a time 5 bombs, which will go underneath the sea at a depth, which they will say 100 meters or more than 100 meters. And then you have, this has to plant those. So this is almost, we are number L1 and T1. Amity is T1 and L1 in the RFP. So we are very likely to get it, and the results are likely to be announced then each time. 21st or 22nd February, it will be most likely we are getting it. So to implement it, and this is not like a 2-year, 3-year, 4-year project. See, this will be 18 months project. So we have to deliver, not publish papers or file a patent. You have to deliver the hardware to these people, which will automatically release the bomb. It will be able to hold the bomb. It has to go to the depth using the third system. And Sujata has prepared something on autonomous underwater vehicle in a very, very basic way. But then now here is a mission which is coming. So that is why this is one mission which we will discuss first. Second one is very critical again. See, now the drones are becoming a big menace in the borders. They are dropping bombs, they are dropping drugs, they are dropping weapons. And so you have to detect the drones as well as neutralize them. So drone detection, and then you have a soft kill or a hard kill, kinetic kill. So this, how do you interface these two? Detection is over. How do you set it for actuation of your response? This software, the computer science, that's why I called all of you computer scientists. We have Tanya, we have JK for signal processing, Sujata for the autonomous underwater system. So we have all these people. Now he will explain the complete problem definition, but I need people to who can work, not only faculty, because you people are busy, and some faculties, who are the faculties, some students whom you feel they have aptitude, they will sit late in the evening up to 9 p.m., 8 p.m., they are hostelers, so they, now the winter is over, so we want to put a big team, we will give some money to them also, a stipend from the project. So that is why I want strategy, how do we execute it in the time frame, 18 months, the hardware to be realized, and then to be delivered, and we will do it. We can do it and we will do it. Now over to you, Prasad. You define and what you have thought of, what is the stage of these two projects?
It's only for that radar nonsense meeting.
No, it's also for the ROV because I want commitment from them. I will give two M.Tech students. I will give 3 B.Tech students who will come. These are people who are interested, motivated.
Like,
Yeah, please. First you define just this one and then go to the other.
Then I will go to ROV because ROV PPT is not here. It's a very
No, you can explain.
Right. Good afternoon, gentlemen.
Give the
I'm
mic.
taking your time for two fundamental reasons. That a group of, the running group wants us to build a system which they are making a radar which is going to track the drones. They are having a radar for tracking the normal drones and micro drones also. That radar is built by LETI, and actually it is a BFSR radar, battlefield surveillance radar, working on X-band. Now they want to design a neutralizer and artificial intelligence built in to classify the radar, drone. When they get the radar returns, they want to classify which drone it is there. Neutralizer is a jammer. It's not an active system, it is a passive jammer system. We have to design the tracking of the target and the entire interface from the main radar to the neutralizer radar. Why sir has called you and myself interested in talking to you is the time is only 6 months. It involves hardware design, total hardware, 2 prototypes have to be given, as well as software design and an interface to the radar display. If you remember, must have seen the radar display is a polar display. So we have to interface all display into the radar system. Since the time is less, okay, I request you people to come out what contribution you can do and what help you can do, because it can't be a paper writing problem. We cannot handle the problem like a paper writing. If you say yes, then we work 10 hours a day. What's the problem? Can I, sir?
Yeah, please.
No, no problem. This is the radar which they have got. This is the system which they will get it. If you see, they have an array of antenna. Then they got one monopulse technique. As I told you, it is a battlefield surveillance radar. So it is supposed to be mounted in field all along the border.
You can use the mic, so that you can use the mic.
Sir?
You can use the hand mic.
Okay, sorry sir. So they have put a monopulse technique also so that they can get the azimuth and the direction of the target very correctly. Although it is not required, but since it is built into the radar, so we have to provide the interface outside. Then they have signal processing system, operator control and display. This is the RF timing and distribution, because every radar requires a pulse width for a particular direction. And we have to provide interface with this. What system I had suggested was, these are the couple of jobs which we have to do. Receive I and Q data, from the exciter. EX and RX is the short form of exciter. We have to carry out digital pulse compression. Then we have to do moving target indicator system. Coherent integration is one of the things which we have to do it. Then constant false alarm rate processing. It's a method of doing radar processing. Monopulse error estimation and to estimate direction of arrival. They are not doing it. I forgot to mention, Colonel Gopal had the meeting with them and we had a couple of presentations with them. Only one presentation. When I gave the solution, what solution is there? So they have added a couple of this. Tracking of the drone, and they want to track mini micro drones itself. This is a solution, general purpose radar works like this, and this is the solution which I have given them. And these are a couple of my own algorithms, which I have told them we will try and put it across. This is a total system design. The signal processor is based on FPGA. I tell you why, because the total processing time required will be about 85 milliseconds. Although they have not told me, but see, the BFSR radar was designed by me about 25 years back. So I know the timing constraint would be this much. So my solution I have given them to make it, on the FPGA plus DSP. There is no other processor which can handle such type of data. For CFAR and tracking, I have suggested a separate processor for that. Then this is the optical interface from the main radar to my signal processor. we are providing optical fiber, single mode optical fiber interface, and this is a general purpose unit which will give system monitoring, control function and display. This could be anything, Raspberry Pi, or if you are happy with any Intel product, this can be there. A couple of suggestions I have given that they are not using the latest method of pulse compression. So I have shown them that we can use some code which is known as Barker code, which will give them better solution. And these things are mathematical fiction. Why I put it across to you that look at the computation which you have to do it. I want help in this. You have to do this type of so many types of IFFT. Optimal filter design is this. This is my design. We can put it there. But my request is somebody had to come up and say that okay, I will code it on FPGA or I will do it like this. Because it cannot be done in C language, Python, Cobra, or whatever language. Whatever. Very good PPT. This is the presentation which I gave it to them that what is the problem, how I can design your system much better than they are having it. So they have agreed on that design. The entire design is not here. About CFR processing, this is the way we have to do it. You look into this, I've got 12 delay lines. Without that, I cannot process it. These are the method to process CFR, right? So this is another block in which somebody has to work. And tracking is another problem which I have told them that I will use. Yeah, good. These are a couple of more techniques which I explained it to them. It's not for you. When we commit, we are going to do all these things in the hardware. This is the hardware diagram, in fact, which will be coded into FPGA. Or this is also a hardware diagram which requires coding in the FPGA. They have agreed on all these designs. Their engineers have agreed and they want us to go somewhere and discuss more about this thing. This is what they said. We are suggesting mounting a camera. For the tracking, I have already suggested we need Kalman filter for tracking the target. They said, yes, we want that thing to be mounted. Now they are collecting the data of this. Nobody has collected the micro Doppler of the drones. This is one of the important data. So I have told them how to collect it, or they will have to give the money so that we can buy all sorts of drone and do it here somewhere in our. This is the software which we have to write. Either standards are DO178 B and C or DO2167 alpha, which is a defense military standard. We have suggested them C, C++ or Python, whatever is possible. All these they have agreed that what we have to do and how to go about this. We have also suggested, somebody told them to use ensemble learning model. So I said there are better models which we can suggest you for classification of the drones. So it is open to us. This is a part of artificial intelligence which is open to us. These are the methods which we will have to follow. My request is that our clock has already started, but I am scuttling the clock. Scuttling means the clock they wanted to start on March 1st. So I'm putting it in a different loop. I want your views who can help us out, and helping does not mean I'm not interested in a Scopus ID. Let me be very clear about this. A Scopus ID, we have published so many. So hard work is required because 6 months, as Sir said, It's a prestige issue if we accept 6 months. Maybe 1 or 2 months I can buy it, because the documentation, I will tell them your document is not correct, your voltage is not correct, something I can do generally, but not more than 1 or 2 months.
See, first let us discuss the technical part. Technical part is already defined. Any clarification you need, you people need.
Anybody, any questions you can ask me.
Then we will see how to go about in realizing this. I want you to suggest, okay, I will give 2 students, I will give 3 students who will work and they will get a share of it in terms of the whatever the remuneration will give them as a stipend to them. And see if they work beyond their call of their duty. Okay, now you want to ask.
So vibration analysis, the part we can do that.
What?
Vibrational analysis of the drone. I've
No,
seen
that is only for,
No,
that is for classification.
If it is required vibration analysis, we can do that.
When we get the drones, we can.
साथ साथ अभी there must be some software, you are saying CNN, which is able to differentiate between, let's say, live birds and the.
Yeah, I have got that. That's an image
There
processing.
must be image processing.
Yeah.
When you say CNN is a well-established technique. CNN is a well-established technique for recognition. So I think to make the research program more simpler, it means you are looking only for the algorithm or the software to differentiate between the bird and the.
No. Entire hardware. It's a very small part.
Then you said BFSR is already there.
No, but the neutralizer is a different.
No. First is recognition. Neutralization comes later, na.
Huh.
For recognition, first you will say that yes, here is a foe.
For that, what I am doing, they have got a radar. I know that radar is a BFSR, but they are not telling. But they got a radar from LRD to detect the target.
Yes.
I have told them that classification is not detection. Detection, after that, I will have to do classification, so we should have some feature vector and some technique. So they have agreed. But the question is, we have to take suppose you have detected me, now you have to give this data to the neutralizer so that he can put the jamming beam there. So this entire hardware has to be made by us. And tracking.
So for the
AI is a very small part.
identification is tougher than.
That's why I suggested him camera. You use camera, you can use my software.
Do we also know about the signatures of?
No, sir, we have to collect it. They are collecting it. They did not know about it, so I told him that without this, nothing will happen. So I have got some signature of Chinese drones, phantom drones, not of all drones. So I told them unless you carry, so Ahmedabad or somewhere their headquarters, they are trying to do that, sir. Acoustic, optical, acoustic, I told them how to do, and vibration, micro Doppler, there is a.
Go to the mic.
Yes.
Gopal from our office, we have asked you to introduce.
Sir, I will be adding some more information to it, sir, as it has been told to us by them that basic radar unit will be utilized what is available with them. So we need not do anything about the major subsystem that is in DAR. And all other software, what they want us to do is they actually want to call us there in their premises and do the entire experimental work there for the first 1 month or 1.5 months. Which I said, sir, this may not be possible because whatever infrastructure is to be created, we'll try and create out here. And we need to create the complete manpower which is concerned with it, including developing of the software, sir. So that sort is to be now discussed. What support can we get from all the other departments which are there? So because as Dr. Prasad has already brought out that this is the today's requirement, what has been spelled out by them. But the other requirement as we proceed with the projects, with the production of hardware and also the software, we need to create those infrastructure with us. So this is what is basically today what we want to discuss is what kind of support, what kind of expertise in terms of the manpower, in terms of the technical know-how and infrastructure. That is what is the main important thing, because the time available is very lesser. They want us to complete this production in 3 months.
Kalyan, you want to say this? I want now the computer scientist people to speak, because this is a software development. But the primary component is software, and in addition there will be supporting hardware.
It's not fully software, sir.
Hardware.
Software is a part. Pure software is a very small part. We have to have a hardware on which software
That
will
is,
run.
Yes.
that is Xilinx and all can.
Otherwise it will not work.
Right. See, you already have a radar, you already have an actuator, as well as you have the neutralizing system. They are looking for hardware and software which will integrate these two.
Neutralizing system, they don't have.
No, they have.
I will show
Not,
you.
we don't have to develop. See, ultimately it will be jamming. It will be jamming, na? Sir,
Yes, sir, it's a jammer.
you will neutralize it by jamming it so that the control is lost.
2200-watt jammer, the beam is 2 degrees beam. More than that they cannot afford.
So that is the neutralizing.
That's a jammer.
They already have it.
Sir, I just tell you what part it is.
So can you define the hardware and software required to be developed by us?
Sir, if you see, this is a hardware, this is a chip, this is a chip. With associated hardware component, this chip will be programmed to do a particular function. Something like, suppose, sir, this is the equation I want to solve. So this or this I want to do. So this will be done in that chip.
Yeah, so you will buy these chips. You will buy these chips.
Actually, these are programmable chips. You can write a code either in some hardware language or in MATLAB, and you can put it inside this chip.
Generally, sir, like I have shown you that spike, I just wrote a program in MATLAB or C language and showed it. This will not work because the time of once you get the blip and our reaction to that is 85 milliseconds. Worst case 90 milliseconds. So in 90 milliseconds, we cannot compute this.
So these programmable chips you will buy out.
Yes.
No, we will buy it.
The FPGAs or ASICs, but I tell you. And then we need to write some.
So now tell us, how do we realize
This
this?
is
So they have understood technical part.
This is available.
Now, okay, now let them say how we can help to realize. Like for example, any faculty who can be identified, whom you feel that they are inclined to work on such challenging project, who are available, who are working with you, because you people may be busy, but there could be. What is your field?
So, Sandra Sharma, my field is computer science, engineering, cyber security, and networking.
Right, right. So, is it challenging for you?
So, this is a good challenge, I must say, and we can try along with the faculties and the students.
Right.
The programming part, if they are talking.
Just note down her name. What's your name full?
Dr. Shilpi Sharma.
Shilpi Sharma.
Yeah, what you are planning to do?
So, if I go with this project, right? So the project.
Just give the mic.
Planning.
Just speak. Sit down and relax and speak.
Yeah.
No, madam, I'm not asking, I'm not taking your interview. The problem is, if you say, and if sir starts the clock,
Right.
then 180 days, I'm not going to listen, you are in examination or you are writing a Scopus index paper, you are in conference, no.
I got the whole thing, right?
So let me very clear and then tell me. Because I'm not going to hang my head. I'm very
So if we
clear.
can get a day of time so that we can discuss with the faculties and the students regarding this, because this is the computer science and engineering. Yeah, because I did have sir.
Sorry.
Yeah, can we have your chance?
Okay, so I expect you will work on this?
Yeah, sir. I'm into it.
Very good.
Let me have a
Both
discussion with.
FPGA or TMS?
So I need to
Are you DSP expert or FPGA?
So, sir, I'm more towards encryption. more towards encryption and decryption technique. So it can be helpful. We can implement it.
क्या encryption करती हैं?
So for the coding, the software coding, the software coding that.
अभी तक क्या किया?
Sir, interview बाद में ले लीजिए.
No, I'm happy. Let's give a big clap to her because somebody coming and saying that, I'm so happy. What about you? Natasha, just give the mic.
Country works.
Give the mic, please.
Natasha को mic.
No, please.
Thank you, sir. So, I have seen the specifications earlier when you have sent, and one of the faculty whom I checked is Dr. Neeraj Khera, working in this field, and I suggested his name for this project. Apart from that, there is a possibility of finding a good student who's good in C++ programming, and whatever small parts sir is saying, we'll extend full support and provide a good student who's willing to work here till 9 p.m. or till 12 a.m. in the morning.
So please note down.
मार्क से आपका वो क्लास कर रहा होगा ना?
Sir, semester March class कर रहा होगा
So Natasha, so I'm so happy that we will be a part of this along with the faculty as well as students.
The faculty is a faculty of EP, not of IT department. Looking at the specific.
Natasha, he's not into this. इसको area नहीं है research.
I had shared the specification with him earlier.
Sir, I know him, which area he works.
Right.
What is the area?
So,
Sir,
for
actually,
student, for a student who works in C++ and has good C++ coding skills, that is essentially required. They may review the student.
Yeah, and select a brilliant student, committed, devoted, and who will work beyond the
There was an industry which came as you suggested to give small modules. So we have assigned 3 students who are getting internship, coding and developing their application. So they are getting a stipend of around 15,000 from that company.
Gopal, take the name of the students and faculty. I will talk to them. I will talk to each one of them. I will every day review, sit with them and see that this is realized. Okay, Prasad, we will first take it. Say,
Student are not dependent because I've seen a meeting with you.
no, but don't worry. You will make them work. We will not realize the potentials of our. Sudhata, just give the mic to Sudhata, please.
I'm audible. ठीक है, I'm audible. Sir, actually in this project, what I feel is that we need people who are working in the area of hardware coding, and particularly maybe in MATLAB or HDL or in C sharp.
Okay, speak.
All they can, by using this, they can work with DSP processor as well as with FPGA.
Okay,
Because-
so let's be very clear. I do not
Otherwise-
want, there is no MATLAB Bangam here, neither C sharp.
So at least
If
you
you
should have
have to
Verilog
do-
or HDL. Without it, how you will code it?
No,
How
I'm coming.
FPGA will be used, sir?
अरे
Otherwise,
भाई हम बोल तो वही रहे हैं, हमें FPGA और DSP chip programming करना है. Algorithm, I will tell you what to do.
नहीं प्रोग्रामिंग तो नॉर्मली FPGA में हम HDL से ही करते हैं सर.
वही तो मुझे भी
We
मालूम
know
है.
hardware.
तो आप करेंगे
नहीं, I am not expert. मुझे आता है, but not to that extent what
तो
you
कौन
have.
करेगा? मुझे नहीं.
है ना?
Please
वैसा
suggest the name of faculty. Students.
Sir, how
one is
about
working
getting
in
some
this big way.
hardcore student from outside?
हाँ वो मैं कर रहा हूँ. देखिए क्या कहना है, you are correct. We will position 8 to 10 people from outside, but we also have to show our core strength. वो billionaire company है. They must know that we have some core strength and then we are buzzing this. That's why I am
Core
requesting.
sir, I think you can include some faculty from ECE department who
मुझे
are
नहीं
into
मालूम
hardware coding.
नहीं
नहीं ECE
कराएंगे क्या? ए रायसा में
Sir, madam बताएंगे, madam कराएंगे.
मुझे नहीं
Let's see if she feels.
आप नाम बताओ.
So now-
9 to 9.
Now please give the name of the person.
People who can work
Dr. Rai is
9
the
to
head
9.
of the department.
Okay,
I
Rai,
think he can.
just speak up.
Because I am also into it, but I cannot do
The
such
person
coding
who
that
can
level.
work 9 to 9. No exam
You
duty.
have to hire people or pay them well so that they work 9 to 9. Students are not going to work 9 to 9.
वो तो हम कर ही रहे हैं.
मतलब वो आपको सपोर्टिंग रोल दे सकते हैं.
जब किसी को आप बोलने जाते हो कि मैं इतना बड़ा आदमी
नहीं सर,
हूँ,
वो
तो
बेसिक को
कुछ
आप
तो
बता
घर
दो,
में
बेसिक
दिखाने
चीजें
लायक चाहिए.
पढ़ते
अकेला मेरे बोलने से थोड़ी चलेगा।
सर आप दिखाने के लिए तो देखिए फैकल्टी
हायर करेंगे।
हायरिंग की
I think कोई faculty अब गया expert नहीं है।
मीटिंग में आने नहीं चाहता है।
Sir, can we take some
एक पैसे दोगे तो सब कहीं कोई
जब दिखाने के लिए रखना तो 2-4 फैकल्टी रख लीजिए, आप बाहर से काम करा ही रहे हैं, तो दिखाने के लिए रख
I think अपने कुछ faculty चले गए हैं जो
वो कर सकते
हाँ वो कर सकते
बिकॉज इवन आई एक अभी डिजाइन किया है संजीव कुमार, ही इज एक्सपर्ट इन दैट एफपीजीए प्रोग्रामिंग में, ही इज एक्सपर्ट। आज वो कैडेंस में गया है अभी वो एक्सपर्ट है, वो कर सकता है।
तो वो
आशुतोष कर सकता है। ये सारे बेसिक इन्होंने हार्डवेयर कोडिंग स्टार्ट की थी, इंडस्ट्री में चले जाते हैं ना, हार्डवेयर कोडिंग तो नहीं रहेंगे।
सर जो आपका एआई मॉड्यूल है जिसमें एआई इम्प्लीमेंट करना है, उसमें हम अपने सॉफ्टवेयर प्रोसेस से देंगे।
मेरे पास बना हुआ है, I will take it.
सब है फिर चाहिए
समझो आप
मुझे हार्डवेयर बना के उसमें कोड डालना है, मैं अकेला क्यों डालूं? Why there are so many people in a meeting? Why should I take the brunt? Question is, why should I take the brunt? I want people to get involved.
अगर ना नहीं सर आप है ना जो
See, madam, when people come and say हम 200 स्कोपस लिखा है, तो come and work here.
वो थोड़ी है सर, there are faculty वो train up कर सकते हैं।
Prestige is
they
too.
know the basics.
Prasad, sit down.
Sir, they know to work with the DSP process, they know to work with that. थोड़ा सा अगर upgrade करेंगे तो they will learn. वो आ जाएगा।
Okay, Prasad, now it is my responsibility. They will all agree. I will sit with these students. So please ensure you select the right students. See, we should have faith in people. Otherwise you can't do anything in this world. I have faith in my faculties. I have faith in my students. They can realize, provided you give the motivation, select the right people, and pre-select is a very prestigious. Then we will get many projects like this. Prasad, we should take it. Now they have published papers, they have filed patents. Now the next step, we are graduating, evolving to develop products. That to strategic products. Imagine if we can deliver one to the services, then there will be 100 projects coming like this. Okay, now the second project, ROB. Just we will define one more project. That is 5 crore project. This is an industry project. The other one is a much complicated 5 crore.
Just a second, sir. I don't think I've got the.
No, you can just define. Because we must now take such projects. Natasha, isn't it? Now it's working 20 lakhs, 30 lakhs is all right. That phase is over now. Now we have to talk in crores. This is 5.4 crores or 5.8 crores project. Which is already
that should be the starting amount now.
Yeah, and that is starting. Once you develop, then scale up and all that, we will get into bigger programs. Now the DRDO can give 50 crore project, one project. So we should now think like this. How do we deliver it? It's then nothing will be. We can do it, we will do it. And Amity, I have realized, once you are determined to do it, anything can be done.
Yes.
Anything can be done. I will bring, as soon as the sanction letter is received, I will inform Chancellor, I will inform Founder President, I want this to happen. So they will get involved, then mountains will be moved to realize the system, which Amity is capable. This I have realized. 11 years in Amity now. So I know your strength. All of you are wonderful Hanumans. Hanumans, you people can realize anything in Amity. You can live Parvata. So that is why, I want you to realize this. Let us bring such 50 crores, 100 crores, such kind of programs we should bring. Over to you, Prasad.
I'm just not. I don't have the PPT here.
No, you can just leave. Just.
लिख सकता है.
तो बंद करो, फिर you can write on that smart board.
24th of February, sir has to sign the final paper.
You give the mic.
We are getting.
ये लो mic.
इसको board smart board करो. And Ashish Mani, I want to ask you how you can.
This project is the cost is immaterial. It runs into 5.5 CR. we have to design a remotely operated vehicle, that is a submarine, which is supposed to work at 100-meter depth of water under a sea current of 1.2 knots, and its range should be 3 kilometers. It's a tethered vehicle, means the submarine is tethered with a rope. The maximum weight cannot be more than 30 kg. We have to put side scan sonar and we have to put high speed imaging system. The problem is that we have to design the entire hardware as well as the software which will detect underwater mines. Main job is to detect the underwater mines with the side scan sonar signal plus image processing. Plus, we have to have the launch control from a ship. The control will go through the tether to the submarine.
You want to use the board, you can.
ROV.
Quickly.
What do you want? See, this is the C button. So you find that this is the.
Even there it's not visible.
So ROV may not. What we are saying that ROV will look like differently. I'm just drawing a box. There are reasons for drawing the box.
ये color change करो ना ये पता नहीं ये
This is the remotely controlled and this is the sea level.
Sir, actually this is too
Dark blue.
a darker color would be better.
background dark करो. हाँ ठीक है now you write.
Sir, this is the ROV is not a cube. It will be a different shape. Why I have shown that it will have 6 propellers. That's improved. It will have 6 propellers. Number 6 propellers. Why 6 propellers? Because they want the entire ROV to have 6 degrees of freedom inside the water. Then we will also have a robotic gripper here. I have the design. I wish I had brought this. Now this gripper is supposed to pick up 500 grams of explosive inside and place it wherever they want. What is the payload? Side scan sonar. Side scan sonar. Side scan sonar we have and camera. Now this camera is an underwater camera. I have suggested them in my design the resolution of 2048 by 2048 camera working under the lighting condition of the sea. Now this is the tether which will go from here to the parent ship. This is the ship where you will have the control. These are the people who will be controlling the movement of this. Right. Now what is the software is entire control of this underwater, control in 6 degrees of freedom, robotic control, then the hardware, how to design this. Because the weight limitation is given and it is 100 meters below the sea. So when I put 100 meters, every 10 meter depth of water, you have 1 atmospheric pressure more. So inside around 100 meters, it will be 10 times of the present atmospheric pressure. So we have already taken I have given in the design, that's how it has come first. What material, how we will do it. And what important thing is, we have to design the intelligent software which can detect the mines inside the mines with the help of sonar and the image processing. and a total control system through which an operator on the top can control the movement of it. Now, the biggest problem comes, generally submarines have ballast tank. Ballast tanks are empty tank. What they do, as they want to sink, they keep filling the water inside that. And there is a depth measurement system which keeps measuring the depth and telling them I am come to this depth. So they do not want ballast tank. They want a passive method of depth measurement and system. We have worked out a method that how do we do it, and we had to also find out how to bring it up. So all these things are there. Then they want the location of this sonar. I mean the ROV, which is known as ROV. So they want to know where is ROV.
They ulta.
Well, ulta. So they want to know the location of the ROV. Generally in the submarine what happens, there is a technique known as digital baseline. But like if you go to Bombay or you go to Vishakhapatnam, there are 10 kilometers of sensors laid down. That is known as digital long line. We cannot do that, so we have to come out with the technology to track, find out the exact position of that with respect to the ship. I have worked out a method that since the ship position is known, we can calculate it. One of the problem comes that most of you must have heard, Dr. Perwar has got. Generally, it's a mechanical device. When you put it into the water, it will take a shape of catenary. So we have to calculate what is the weight of this coming on the load on this. Right? This is another tricky thing which we have told them some solution, but we have to work it out. This is the ROV problem. In nutshell, we have to make the entire thing and we have to qualify. EMI, EMC qualification we have to do. We have to do the depth measurement qualification. Then we also have to do sea state simulation. That if sea is at a state 1, how it is going to work. Because they said, I will classify, entire thing has to be classified, complied with all this, and then only they will accept it. This is the nutshell. I will have the PPT. People who are interested can come. I will show you the entire PPT.
In nutshell, what is the technological challenge? It is just the assembly, or there is a technological challenge also in this? इसको बनाने में कोई ऐसी टेक्नोलॉजी है जो हम एक चैलेंज है जो अवेलेबल नहीं है या डेवलप करना है, या it is something small technologies they have to assemble in this customized or in the requirement?
No, there is couple of technology problem like how to get the propeller. See that on the ship there is a small propeller and fitting it in 6 directions without interference and control is a big one. So that propeller we have to find out, otherwise we may have to get it from Singapore.
Why I raise this? If we can spell out those challenges in this way, so the faculty they would be able to respond far better that.
Right. Can you just give the mic to Sujata? Sujata, you have developed the third system.
No, actually, this project, myself and Dr. Soni, we have presented under.
Yes, sir, we have discussed.
Sir, we have already discussed with sir because we have in 2 years back we have presented it in. Yes, sir, you have sent us there. But I don't know why it was not sanctioned and all. But it's similar.
Now it is getting sanctioned.
Even the gripper and all.
Now it is getting.
Yes, so it's good.
Sony इसको करना है.
Good.
इसको at any cost.
For some testing also.
For that, I leave the job and joining you.
I had written their name as a co-PI. My name is not there. PI is Shivani, co-PI are these people.
These are the two.
So they have to leave their office and work.
Yeah. Okay. Now, anything else people would like to say? See, these are challenges. One is just doing passive life. Here it is a warrior. You are like a science warrior to realize something and then give it to the country for the Navy. for national security. So imagine so identify, the action will be, first you understand the problem, look at who can do this. See, you people may not have full time, but you may have some faculties who are inclined, because in assets, so many people don't have any project. Yes, they're all there, not many classes, and so why don't you pick up some faculties? So that is right. First thing, Sujata, if you can identify Sony, that who are the faculties who are willing, not that just because they don't have anything, then just dominate, but who can deliver. You have some knowledge.
Some expertise.
And the expertise. Second thing is students. This population, no, we have underestimated. There are many, it may not be everybody, but there could be out of 100, 2 students, they are research aptitude, they want to achieve something. And our MTech defense technology, they are nothing but this is the project. Come and work them, they are full time, they should work on this. Instead of going to another industry, here is an industry. We have an industry here. So we will work, maybe out of.
I think they can work directly.
So they can put this as everything, some part can be the third mechanical system, mechanical engineering part. And the electronic particle processing and others, somebody will do that. And then realizing the robotic arm, which will drop the bomb. So like this, you give it to each one, they will be interested.
I'm already identified, I'm just thinking.
Very good. So you note down, Neeraj will play a very important role, Sujata, Sony, and who else can contribute?
Electronics
Now, Ashish Bani, you have already developed a 3D PCB prototyping system, and using that knowledge and expertise, what is that you can do in this ROV or even the other one?
So I don't work in these areas directly, but following the discussion, it appears that these are not research projects, but engineering projects.
Yes, correct.
And they have to be delivered in time-bound fashion. So why don't we use engineering methods? Engineering methods are widely used. Eiffel Tower is created by that method only, well established. It has got 4 phases, well documented, basic engineering, where we have the block diagrams and the basic idea and a design document, that is basic design document. And then we have a detailed design engineering, where we can assign individual modules to each of the faculty members who want to be part of it. And further is the prototyping stage, where we can involve the university's lab facilities. You can use my facility also, my lab facility also. AIDC also has got a facility. So, and then the testing phase. The final phase is testing phase, where we can test it against these specifications and then iterate, right, till we get the. I can help in managing it.
Right. Okay, please write down. Ashish Mani will also be part of this team. Now, Neeraj, आप बता कितना स्टूडेंट है?
मुझे काम करने के चाहिए।
हाँ काम करेगा।
Redefine नहीं चलेगा सर ना, redefine नहीं चलेगा कि मेरे को बच्चे they are learning it.
Student सर ये ऐसे एक बात बताऊं, we will keep अभी कोई we are not reaching to the solid grounds. Let me tell you very frankly, नाम लिखने से ये प्रोजेक्ट नहीं होगा। नाम लिखने से I think पहले इसमें spell out करो कि what are the challenges. अभी मैं बता रहा हूँ what are the challenges, who will solve those challenges, as you said, it is not purely an engineering project. No, there are certain technological challenges which need to be done. उसमें हो सकता है थोड़ा research भी करनी पड़े। तो उसके लिए पहले इसको बिल्कुल वर्क ब्रेक डाउन करो, जो इसमें क्या चीजें, then someone will pick, I can solve this, I can solve this, I can do that, है ना, मानते हो? उसके बाद then the confidence of the team will build up, then people to integrate and go up.
If the people wake up, I will help you, there is no problem, I will send you a design document. Preliminary design document.
So action point will be first action, Prasan. Both the proposals sent to all the people. Okay, so they know what is so they will start thinking how, which student, which faculty. Second thing is action plan for each one of this, particularly ROV, the engineering critical design review, preliminary design review, and the engineering drawings. So, and which part?
Sorry. After proposal, the PI or the lead should spell out, rather than they explore what needs to be done, he should spell out that what needs to be done, what are the likely challenges.
Right. Okay. Okay, Prasad. They are ready to help you, and we are all with you. You go ahead, full steam, you will realize this.
Lip service, I'm very sorry to use the very blunt language. Lip service will not help. If you are interested in knowing the technology, publishing the paper, come and sit down with us. You please publish, but help me. It is a prestigious project which is going to Indian Navy. It is not going to XYG. Why sir is after Adani? Not that we are interested in his money. The problem is, it's the most, he is getting an order of 1200 crores in August for army. So everywhere our product is there.
So okay, they will realize it.
Sir, rightly said, there are so many Hanumans, but few Hanumans are missing the CCFM. So we are encourage them, and we need those Hanumans are also need some blessings and help, and also few faculty members have left our organization at MIT University. Their help maybe seek since they have good in programming and VLSI digital or in PG or DSP which we are talking about. So we can explore how we can take services of those faculty members, though they are not working in the industry.
Good. Let us do it. We will do it. Thank you. Thank you.